How's it going, Calc class? Welcome to 3.1, derivative of a function. We're getting into the nitty-gritty of Calc, guys. When you find the derivative, that is the function that gives you the slope of the tangent to any given point of the original function. You take a function, you take its derivative, okay? That derivative, plug in any point that's in the domain of the function, and you get the slope of the tangent. So we don't have to go through and use that crazy limit way to find out every point when you could just do it once and then plug in the points. Okay, that's what a derivative is. That's what calc is. We're going to be doing derivatives the rest of the year constantly. Okay, so let's take a look at the definition. I don't need this, I'll charge the pen. Right here, the derivative. The derivative of a function, noteworthy, is wrote f prime of x. That little apostrophe means prime. That means it's the derivative. If you put two of them, it's the second derivative, and three of them is the third. Five, you get it. Okay, you made it to calc, so I figure you can do this. Okay, and here's your definition. It's the limit of, well, look at this thing. It's the same equation we had before, but instead of a, there's an x. Okay? That's it. We're doing the same thing, but instead of plugging in a point, we're going to plug in an x. Okay? Now, just some side note here. Make sure you understand that the domain, you can only plug things into your f prime that are in your original domain. Okay? Anything too scary? Well, let's do some derivatives. Whoa, I forgot. Curtain. Okay. Actually, on this. This is definitely an example you guys need to know how to do. Suppose you have to differentiate your original function as x squared. And this is, if you remember right, it looks like this, right? So hopefully we get a function that as you plug in bigger and bigger x's, you get bigger and bigger slopes, because x squared gets steeper and steeper as it goes up, right? Right. So our first step is to look at our equation. Our equation for a derivative is f of x plus h minus f of x all over h, the limit as h goes to 0. Okay? I write this down every time I do a problem. Next, we plug in our x plus h in for our original function. So basically what we're doing is we're taking this f, or x plus h, and we're plugging in for x, right? And that's how we get x plus h squared. Okay? And also we take orange. We take our x and we plug it into our x squared. Okay? Same thing we did before. You plug it into your function. Next, you have to expand that x plus h squared, and hopefully by now you're doing that a squared plus 2ab plus b squared, because if not, you're going to have some problems. If you still don't get that, or you still don't like that expansion, look up binomial expansion on YouTube. I'm sure you'll find some great videos that will really help you out. Okay? Because I know you know how to get on YouTube, because this was YouTube. So we expanded. Now you can see we have an x squared minus x squared, so those go away, right? I'm going to grab my Moby utensil. And you end up with a 2xh plus h squared. And then they factor out in h, okay? So that's what's going on right now. They're kind of jumping the gun a little bit. I wouldn't factor that h out anyways, I would just cancel the cross, but to each their own. So again, your h's cancel. and you're left with 2x plus h as h goes to 0. Now, I told you guys when you do this, you're going to end up crossing off all your h's, so that's what you do. That h is just going to go away. Okay? I'll lift the curtain on the show. So your derivative after all this mess is just 2x. What that says, I'm going to draw it. Oops. So again, good old x squared looks like this, right? That means I can find the slope of the slope to the tangent at any of these points just by plugging it into this equation. That means my slope of my tangent at when x equals 5 is 10. Let's say this is 5. So my slope is 10 at this point. Okay, that's the derivative. That's all there is to it. Ta-da! Ta-da! You guys want to see another example? I'll take this, yes. Okay. Let's say I ask you to find. This is the same thing as asking for a derivative, guys. In fact, let's do that right now. Here's what I'd write down. I'd write down this, 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 and this. These are all the same notation to call something a derivative. Okay? These are the most common. Prime, the derivative of y with respect to x, derivative of the function with respect to x, and derivative dx of f, your function at x. Okay? The derivative of your function at x. Okay? I'm going to use all these so you get used to them, but they're all saying take the derivative. Okay, they all mean the same thing. Quick time check. I'm back. So again, let's say I'm finding d over dx of your f of x, which I can actually just put. I'm a mess today. Of 1 over x. Okay, so that's my function. Okay. So again, I'm using my f of x plus h minus f of x all over h, and it's the limit as h approaches 0. Okay. So first things first, I'm going to take this and I'm going to plug it into my original function. Okay. So that's what f of x plus h is. So I get 1 over x plus h. Okay. Oop, not blue. Next, I'm going to plug in my x to my original function and subtract it, which is just 1 over x. And now this whole thing is still over h, and h is still going to 0. Okay. So, now what do I have to do? Let's find a common denominator. Okay. I see an x plus h over here, but I don't see one over here, so I have to multiply this by x plus h over x plus h. Okay. And over here now, I see an x plus h, but no x, so I multiply it by x over x. Okay. So what I end up getting, bear with me, I'm not going to write the limit till the very end. Okay. If you have a problem with that, call the Calc police. Don't call them because they're busy. So this top actually becomes x over x squared plus xh minus x plus h over x squared plus x of h. Okay, and the whole thing's over h still. Okay? Okay, so this negative gets distributed through to both of these. Right? So my x's are going to cancel. Good. And I get a negative h all over x squared plus xh all over h, right? I'm not doing this on stability ball day, so I feel like my legs are going crazy. So I take this and I'm going to shift it down, just because that's what we do. So you get negative h all over h times x squared plus x times h. Okay? Now our h's cancel, and we're left with negative 1 over x squared plus x sub h. But wait, what's your limit as h goes to 0? What happens? What happens? This is going to go away, and your derivative is 1 over x squared with the negative sign here. Okay? There you go. It's a derivative. That means for the equation 1 over x, the slope at any given point is found by doing negative 1 over x squared. Okay? Okay? Okay. We're going to skip that for now. And I decide we'll look at the graphs probably in 2 days. Okay, because I want you to get used to doing these first, and then we're going to do some stuff with the graphs so you can see what's actually going on, and that's where we'll actually end it today. Enjoy.